Okay, good. So we're live and we are about to start our second session. After wanting to do, after doing last week our introductory session with some variables, operators. We spoke about data types last week. We spoke about truth tables last week. And this week, we want to move on to talk about some control constructs and actually introduce some pseudocode algorithms and flowcharts. Okay, so we want to talk about the control constructs, sequence and selection, but I actually want to start, before that with just recapping some of what we did last week to just make sure that enough of us understand what we did, or just to refresh the memory. Okay, everybody's fine with that? Anybody took a read or took a look at anything that was posted to the Google Classroom and has a question? Any questions when we to start off with as well? Oh, good. You're hearing like you said, yeah.
Good afternoon, sir. I'm new here. There's supposed to be a Google Classroom for this class?
Yes, there is a Google Classroom for this class. You don't have the access code to the Google Classroom?
No, sir.
All right. The access code was shown at the end of the last, at the end of the last class. I don't know if you were in the last class, but it is.
No,
I'm going
sir.
to, right. I'll show it on the screen right now, so that you can see the code. And I guess yes. So if it is that you, and right, it's shared in the chat as well. Thank you, Gabriella. So this is that's the code for the Google Classroom. You can feel free to join the Google Classroom at any point in time. The Google Classroom has the link to the last video, so you could watch that, and along with what we're doing today, you'll be able to catch up.
All right, sir. Thank you.
No problem at all. So, right. So we want to go and talk about our topics, but we want to, of course, and if you see me watching this way and this way and this way, it's because I just shifting things around on the screen, right? Right. So we want to talk about, or just recap things that we did last week. I'll recap it very quickly. Let me share my screen, and we are on. Okay, good. So last week we did variables and constants. We did operators. We spoke about data types. And we did some basic truth tables. So I'm just going to recap these in like about 10 minutes or so. Okay? The variables, of course, the variables and constants are named containers which allow us to hold values, such as in the case of if we want to express the formula for circumference of a circle, right, which I believe is 2 pi r. Okay, this is like a mathematical representation of it. But what you might do in terms of doing it for a program is that you will have to put pi and represent pi as a value. And notice that the constant value is declared as using capital letters. And the value R is a variable value, meaning that we could take in any value inside of R. The value R has to be set. Okay? So if we were to write some instructions just briefly, we would have to input R. We don't know what R is. We don't know what R is. R is coming in from the user, and that is whatever value that they feel R should be. And now if I want to store the result of this, we also have to store the result in another variable. Because let's say, for instance, C, I want small c for circumference, is equal to 2 multiplied by pi multiplied by r. Whatever I put into R is going to influence this whole operation here. And the result will be stored inside of C. Okay, again, this is just quick recap. We have operators. We had 3 types of operators last week. Anybody could remember the 3 types of operators that we had last week? Yes, Anaya?
Mathematical, logical, and rational.
Right. So you got 2 out of the 3: mathematical, operators, logical, and I think you missed it. You missaid the word. I see somebody else with his hand up. You could share it.
Relational, sir.
Relational. I think you mispronounced the word rather than miss.
Oh, sorry, real tired dog. So yeah.
That's all right. I know that it was probably a long day at school. So we have mathematical operators. Some of the mathematical operators that we have include what? This is the easiest one. So some of the mathematical operators: plus, minus, multiplication, right? We have multiple types of division, right? So we put in division and we put in both integer division and also we're putting real number division. And we're going to talk about integers and real numbers just now. We also have modulo division. Modulo division. And then we have, of course, exponential to the power of. Right? For our logical operators, our logical operators include 3 things. And I always like to put them in the order that they'll be executed rather than having them listed like this. So maybe we could talk about the relational operators first. The relational operators are what? Are
Equal to, more than, less than.
Right. Equal to, right? Greater than, less than, correct? Greater than or equal to. Sorry,
Not equal to.
Less than or equal to. This is greater than or equal to. And then we have not equal to or unequal to. And lastly, we have the logical operators, which are?
True or false?
No, that's the logical data set.
Oh.
The operators are?
Oh yeah, not.
Not.
And or.
And or. Good. So how do these work? These work based upon the data types of a particular value. Okay, last week we learned data types before we learned the operators, but I'm just going them over according to how we know them to be. So if it is that I have my data types now, I have 3 main types of data types, which include mathematical data types or numerical data types, sorry. Right? And numerical data types include our integers, which are whole numbers, and our real numbers, which are floating point values, like minus 9.2, whereas integers are 70 or 8 or minus 8, be it the case. We have our our character data type. And our character data type includes single characters and strings. And our single characters are any letter, well, that's a numeral, any letter, capital, common, any symbol, or numeral. And then we have strings, which are collections of single characters all held together in one variable. So like we have the word hello, we have the word bye, and we also identify that we could have a single character string. Okay, it's just that that string can have one character in it. You could also have an empty string. Okay, that's something that we will be meeting up when we start to do programming as well, an empty string. So a string could have nothing inside of it as well. And the last thing that we had was the logical or Boolean data type. And the logical or Boolean data type contained what? What is the entire data set of this data type?
True or false?
True or false. Thank you. So we have true and we have false. And I'm writing it in a different color just to show that this is the data set, nothing else inside of there. So you can't have, there's no maybe inside of our logical data type, right? Oh, you know. So we have true or we have false. And now we can apply these operators. We can apply these operators here to our data types, values of our data types. All right, I'm going to put this up inside of here. Lastly, we'll have some truth tables. We're going to cover that too. But we could see mathematical operators in action. So if, say, for instance, I have an integer and I declare a variable of the data type integer, and I say integer A is equal to 12, B is equal to 5, and C is equal to 3, right? So we have A, B, and C. And I have an expression that F is equal to A divided by B multiplied by C. What is my result going to be? What is my result going to be here? Anybody, I want you to try and work this out right now. So we're going to have to do, huh?
6.
6. So let's see how we got that 6. Okay. So we have 12 divided by 5. We have 12 divided by 5 multiplied by 3. We know according to BEDMAS, brackets, exponents, division, multiplication, addition, subtraction, we do the division first, right? We do it left to right. We do the division first in this instance. 12 divided by 5 is, as an integer, 5 could only go into 12 2 times. Okay, so the answer here is actually 2 multiplied by 3, which will give me a result of 6. So we are correct there. We're correct there. But if I had the same, expression, but I declared these variables as real. Real A is equal to 12, B is equal to 5, and C is equal to 3. F is going to have a bit of a different answer here. Okay, F is equal to A divided by B multiplied by C. In this instance now, what is the value of F going to return? What is the value that is going to be returned to F?
7.2.
All right, let's take a look. 12 divided by 5 multiplied by 3. 12 could go into 5, utilizing the remainder now, right? 12 could go into, 5 could go into 12 how much times? It could go 2.4 times, is it? Right, multiplied by 3. 2.4 multiplied by 3 is 7.2. So the answer here is 7.2, whereas before it was 6. And we have a difference there based on the data type. Now let me pause here and just ask, does anybody not understand how I've gotten these two answers based on the data type? Anybody?
So, sir, for integers, you're excluding the remainder when you're working out the equation.
Yes. So when you have integer division, there is no floating point remainder stored in the result. It doesn't matter if the remainder is over 5 or under 5. Okay. So just as a general example again, let me just go to the side here. I'll draw a line. And okay, so this doesn't have anything to do with what's on that side. If it is that I have, again, as an integer division, we have the value of 19, and we divide 19 by 4. And we have, as real numbers, 19 divided by 4. Okay? 19 divided by 4 as an integer is going to give me the value of 4. Whereas for a real number, 19 divided by 4 is going to give me a value of 4.75. Now, it didn't matter that this 0.75 here, that this 0.75 was more than half. The thing is that we cannot hold floating point values in an integer. So we can have 4.999999999. If it's an integer division operation, then the value that will be saved is 4. Okay, that's just the nature of integers. Integers don't hold and don't care about the excess amount of what you call it, remainder, right? And then we have, going forward, we have also, this was just to show the integer and real number remainder, but then we also discussed the modulo division. Let me put it on another page. So we had a special kind of division called modulo division. And let's see, with the modulo division, as discussed last week, what we're going to get when we have int a, and modulo division takes place on integers as well. Int a is equal to 12, b is equal to 7, and c is equal to 4. And again, we have the modulo division is represented by either a percent sign or the word mod. So you could see one or the other. So if we say a modulo divided by b, right, minus c, what is the result of this operation going to be? All right, so I'm asking for those persons who were there last week. What is the result of this operation going to be?
1.
Right, the answer here is going to be 1. Okay, because we'll have 12 modulo divided by 7 minus 4. The result of this will be 5 minus 4, and that will be equal to 1. How did we get 5 as a result here? We got 5 as a result because, again, as I showed you last week, if we did the old school division, 12, and we divide in, not 12 by 5, but 12 by 7, right? We would see that 7 could go into 12 once. 1 by 7 is 7. 12 minus 7 is 5, and that's the remainder. And this here is what the modulo result That's what we want as the modulo result. So this is the modulo result. So the modulo result returns a whole number integer that is the remainder of a integer division. Okay? So this is how we got the 5 there, and then we could say 5 minus 4 is equal to 1. Are you all with me?
Yes, sir.
Yes, sir.
All right.
Sir,
Yes.
you can just go back on page 3 for 2 seconds.
Page 3.
Yeah.
Mm-hmm.
No, sorry, page 4. I think
Page
it's
4.
page. With the data types.
The data types. Page 2.
Oh, yeah.
Yes.
Yes, sir, I got you.
All right, good. These, remember, all of this will be posted to the classroom afterwards as well, eh? Right? So it's just a matter of giving me a day and I will get it up on the classroom. So no need to worry. And if it is that you are don't see it in a day, just message on the classroom and say, hey, send the notes, and I'll send it up for you. Okay. So the next thing that we have, I just want to make sure that we understand some more expressions. Let's see if we have 5 minus 17 divided by 2. Let's assume that, right? We're assuming that it's integers. Assume integers is greater than or equal to 6 multiplied by 3. Let's attempt this. We have some mixed signs inside of here. Well, what is this going to be? Right? So if we say f is equal to 5 minus 17 divided by 2, which is greater than or equal to 6 multiplied by 3, what are we going to get as a result in f?
False.
False. Yeah, right? I believe that is going to be false. Yes. Okay, and how did we get that? Well, we have to do the mathematical operations first and then the relational operations. So we can do 17 divided by 2, which is, my brain is, 8, right. Thank you so much. So then we'll end up with 5 minus 8 is greater than or equal to 6 multiplied by 3, which is 18. 5 minus 8 is minus 3. Minus 3 is greater than or equal to 18. This statement is, right, the answer for this is false. So you see, we have to do the mathematical operations first. All right, we have to do the mathematical operations first before we can do any sort of comparison operation. All right. So that's just use of a comparison operator. And again, I just want to go through the truth tables, right? Quickly, what are the rules with respect to or and not? Or sorry, not and or. Anybody could remember the rules as we listed them last week?
For not, it inverts a logical variable.
Yep. Okay, so for not, we invert any logical variable. So if we have a variable, a Boolean variable a, the values inside of it could be 0 or 1. So therefore, not a will be either 1 or 0. If we have a variable, if we have to take a look at and join 2 variables, and or, both of them, join 2 variables. So we have to have a and b, and we could have all possible combinations of a and b. 0 and 0, 0 and 1, 1 and 0, 1 and 1. So if we say we want a and b, we will get 0, 0, 0, 1, because the only time that we have values for A and B existing is down here. All other times, the only time we have a positive is in these one instances, but we need both instances for it to be true. And then we have or. We have or. We have as well, we can have A, we can have B, we can have all possible combinations of A or B. We have A or B. And the rule for or is, could somebody just remind me, somebody who was here last week, the rule for or?
You could. Go ahead.
Well, either one of them could have a 1 in them.
Right. We only need one instance present. We only need one instance present, okay, for it to be included. So our result for or would be 0, 1, 1, 1, because in this case, we have both instances. We have one instance here, and we have one instance here, okay? So now, let's just take a look at developing a truth table and evaluating an expression with A's or B's, right? Don't worry, we get into the code, but I feel we need to know this stuff here for us to be able to really appreciate what we'll be doing logically when we start to think about code. So, say for instance, I have this statement. I'm just going to put, I'm going to say evaluate A is equal to true, B is equal to false, C is equal to false, and D is equal to true. So if we have some statements, not A and B or C, and not D or A. How do we evaluate a statement like that? Well,
So,
first of all, go ahead.
all right, I was gonna say you have to look at the brackets first.
Right, so we have to look at the brackets first. Well, maybe the first thing we should do is fulfill the substitution. Okay, so let's write it out as it should be. So we'll write out not true and false, or false and not true or true. Okay, so this is what the statement is when we substitute the values, the variables that were holding T or F. All right, and now we could start to evaluate. So let's as Porter said, we can take what is in the brackets first, because that's what we said. BEDMES, brackets are always first. All right, so we could have true or true, and true or true is going to give us a value of true. So we'll end up with everything else here. False, false, not true. And then what is the next thing that we have to evaluate? We have to evaluate the
Not T.
The not, right? The nots. We could do the nots at the same time. So we could say not T. So not T will give us false and false, or false and false. Well, this one kind of works out easy because we only have F, so we could say we know where this is heading. But in the spirit of being correct, we have to work out the ands before the ors. So we could work out all the ands, false and false, false and false, and then we'll work out the or. False or false. So the result of this gives us false. Okay? Do we want to work out? I want you all to just take a couple seconds and work out one more, okay? So I'm gonna do one more. I'm gonna put it up on the board. I'm gonna give you all 3 minutes. I really can't give too much time. All right, I really can't give too much time, but right. So let's do one here. A and B or C and not C or B. All right. So we're going to work out this one. Giving you all 3 minutes. I think I have a timer inside here. So I'm going to set my timer. By the time I find the timer, must be 30 seconds might pass. All right. Applications. Stopwatch. Stopwatch is not cooperating with me today. I don't know why. My application is just misbehaving.
It's F, sir. It's F.
All right, so we have one person saying that is F. I'm just going to give a couple more people a little time to work it out. And this application misbehaving today. I'm going to have to stop it for a second. Restart it and reshare the screen.
So what's that application that you're using?
It's called Open Board.
Okay.
It works perfectly as long as I'm not presenting to people online and recording, right? Then it decides to give a whole bunch of trouble. But yeah, whenever I'm using it, just normally in a non-recorded session, it just behaves itself wonderfully. Never gotten any problems from that stopwatch before. All right, so let's take a look at the solution. I got one person telling me it's F. Anybody else?
See, I agree with him, sir.
You agree with him?
Yes, sir.
Yes,
Me too.
I agree with them as well.
All right. Let's see. All right, again, we have to substitute. So we put true and false or false and this is supposed to stay in brackets. Not false or what? Or B is false and true. So we're going to evaluate the brackets first. False or false will give us false. False and true will give us false. So we have true and false and not false or false. So next we have the nots to work out. All right, so we end up with true and false and true or false. Okay, so this is where we are. Then we have to work out the ands. Okay, the ands, true and false will give us false and true or false. And then false and true will give us false or false. And the final result will be false. So we were correct there. Okay? The beautiful thing about all these expressions is that, at the end of the day, if you're just making a straight guess, it's a 50-50 chance. Well, we don't want to guess on these kind of things, right? We have to know how to evaluate them. So we have to know how to evaluate them. And it is these here, believe it or not, that's similar to just being able to do this, help us with the ability to understand. They help us with the ability to understand the logical expressions that we will put in control statements when we are programming. So it's really important that we be able to at least follow the logic of these things to be able to to track and see how they will be resolved. Because when we have to put expressions inside of if statements and inside of while loops, etc., we would have to be able, as the programmer, to be able to evaluate these expressions depending on what they resolve to be. All right. And the last thing that I want to talk about is truth tables. So yeah, what I'm saying, do you want the result of this to be explained again, Keon?
Yes, sir.
Right. So we started off with some definite values and an expression. Okay, so we know that A is true, B is false, C is false, and D is true. So our expression was A and B or C in brackets, and not C or B and A in brackets. Okay, and we substituted all of the values with the values that they were as expressed here. So we ended up with this statement: true and open bracket false or false, close bracket, and not false or open bracket false and true. And the thing is, when we are evaluating these expressions, we have to do the brackets first. The brackets rearrange, just like in maths, the brackets rearrange the order, right? So we know that in maths, you do division and multiplication first, and then addition and subtraction. But if something has a bracket in it, so say for instance, you have 2 divided by, right? 12 divided by 4 plus 2. In maths, we know that we'll do this 4 plus 2 first, 6. We'll get 12 divided by 6, which will be equal to 2. In the same manner, we do this. So we started off with these. So we evaluated what was in the brackets, false or false, and we have false and true. And this one evaluated to false, and this one evaluated to false. And now the expression became this: true and false, and not false or false. And we didn't have any more brackets, so we ended up eliminating the nots, resolving the nots. So not false ended up being true. So we ended up with true and false, and true or false. But then once we got to only ands and ors inside of there, we have to do the ands first. So we did the first and, which was true and false, and it didn't matter the order of the ands, right? But we did the first, just doing it from left to right. True and false will give us false. So we end up with false and true, or false. And again, we have to get rid of the and first. So false and true, which will give us false, or false, is going to give us false ultimately. So this is a single expression. Right? This is a single expression. And now we want to go into doing the truth tables. Actual truth tables for an expression. So this here was where we were told what each value is going to be. But what if we got this same expression here? What if we got this? Nah, this expression is do we have just A, B's, and C's inside of here? Yes, we could use this expression inside here. And I'll do 2. So I'll do this one after, right? So this is one that I want to do after And we'll do another one first, just to warm us up. So let's say we have an expression A and not B, or B and not A. So let's say we have this expression and we want to evaluate what this expression would be. And we want to create a truth table to see for all possible combinations. We are not told here what A is and what B is, right? This is not a single case. This is for all possible cases. We want to see what the output would look like for this. So we have to do our truth table. How many different variables do we have here? We have A and we have B. Yeah, we have two variables. So we put them down in a table, A and B, and then we look at all possible combinations of A and B. 0, 0, 0, 1, 1, 0, 1, 1. Okay? So we're looking at all possible combinations. And of course, we have two expressions bracketed, joined by an or. Where would be the best place to start here? Well, we start with the not within one of the brackets, right? So we can identify this here as the first thing that we do.
The negation of B, sir.
Sorry?
The negation of B.
Yes, we're doing the not B first. Yeah. So the first thing is not B. All right. Some music coming through. All right. We have not B being done first. And what will happen here is that we look at what is in the B column and we invert it. So we end up with 1, 0, 1, 0. And then the next thing that we can do is we can do this whole expression. So this second expression here, 2, is going to be, the second expression here is going to be the result of 1 and A. So we could say A and what took place in column 1. So we're looking at these two columns here right now. We're looking at A, and we're looking at this column, and we are going to see what is the result going to be when we join these two columns, column A and column 1, using an AND. So 0 and 1 is going to give us 0. 0 and 0 will give us 0. 1 and 1 will give us 1. And 0 will give us 0. So we've evaluated that first bracket out. And now we have to evaluate the second bracket. So we're going to do not A. So this is the third thing that we're going to do. So this is 3. And 3 is represented by not A. All right, so we take what's in the A column and we invert it. So we end up with 1, 1, 0, 0. And then we have to take the rest of the expression, B and not A, and we're going to put it in this column. So what was not A? Not A was the value from column 3. So we say B and the value from column 3. B and the value from column 3. So B is this column here, and column 3 is this column here, and we're joining that with an AND. So we're saying 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. And now the final thing is to join everything together. The result that you get from 2 and the result that you get from 4 using an OR. So the last column will take the value of column 2 and join the value of column 4 using an OR. So what are we going to get here? Right? We're going to get the value of column 2 and the value of column 4 using an OR. We get 0 or 0, which is 0. 0 or 1, which is 1. 1 or 0, which is 1. And 0 or 0, which is 0. So the result, the truth table result for this expression is 0, 1, 1, 0. Right? And that is based upon the input combinations. So if we were to simplify this answer, we could get A and B as the result, right? For this expression being 0, 0, 0, 1, 1, 0, 1, 1, right? So the answer is 0, 1, 1, 0. And this up here is our working, and it is important to show our working. And this working is more important than just having the answer. You follow me? This is how we get, yeah. This is how we get the result. Okay? And just as a note, this expression here is, I'm sneaking it in because it's something that you need to know. It's called an exclusive OR. Right? So this is an exclusive OR. And right, an exclusive OR is a special type of OR which only returns true when one of the values is true. It only returns true when one of the values is true. All right, I felt like I need to sneak that inside there, but remember this is a question CXC loves to ask. All right, so now we have this mean looking one here. This mean looking one here. What do we do in the case where we have how many variables now?
3.
Sir,
We have 3 variables. Yeah, we have 3 variables.
the possible solution, conditions.
Yeah. Marco, you was coming in kind of loud and soft there. You could see it over what you said?
So you have 8 possible combinations, sir. When
Yes,
it's 3 of
you will
them.
have, right. So there's a relationship with the amount of variables and the possible amount of combinations. If you only have 1 variable, you'll end up with 2 combinations. If you have 2 variables, you'll end up with, you'll end up with 4 combinations.
4, sir.
Right.
2 to the power of
And if you have 3 variables, A, B, and C, you'll end up with 8. Okay, this is 2 to the power 1, this is 2 to the power 2, and this is 2 to the power of 3. So it's just something to note, that you can count the amount of variables and you'll know how many possible combinations that you will have. Okay? I'm going to put this a little more to the side in a little bit. Well, no, because I don't want this to be, this is more of a side note thing. Okay? It'll still be in the notes. So how do we get these combinations? These combinations are like a counting in binary. So we can have A, B, and C. And you'll see that a lot of things kind of come together when you're working with binary and logical data, etc. etc. So we have the value of 0, 1, 2, 3, 4, 5, 6, 6, and 7. So these are our possible combinations that we can have. Yeah, yes, Marco.
No worries, sir.
Okay. Right. So we can have these possible combinations, and now we can go through in the same way getting the result for this entire table like we did just now. Right? I really and truly think that it's the wisest thing that you can do is pretty much to is pretty much to label off what you're doing first. So this is 1, and this will be 2. We're doing the brackets first, not so? So we'll end up with B or C in column 1, B or C in column 1. So what is the result of B or C? Anybody, walk me through it.
0, sir.
So the first one is 0.
Second one would be 1.
1.
1,
1.
1,
Mhm.
1, 1. 0.
0,
1.
1, 1, 1.
1.
Right. So we got the result for B or C. We have the second one, which is B and A. All right, somebody else, walk me through it.
0,
0,
All right, so we have 0.
0,
Mhm.
1,
B and A. Remember the rule for and is that both have to be true.
Would be 0,
okay,
sir.
sir.
Yeah, so it's 0 again.
1.
Mm-mm.
No.
We're
Would be
looking
0.
at these two.
Yes, sir. I see it, sir. 0.
Right. 0,
0.
0, 0, 1, 1.
1.
Okay. I keep feeling like I'm not giving enough space to draw my lines underneath. So I'm moving this down a little bit. This is why I like this digital whiteboard though. If you make this mistake on a classic whiteboard, you're in trouble. All right? Right. So we have 1, we have 2. What is the next thing that we'll do? The next thing that we have to do is to take a look at the
Statement, sir.
The next thing that we do is to take a look at the not C. So this is the third thing that we'll do. And watch the result that we'll get here and watch what will come up at the end. So not C is the third thing that we'll do. So 3 is not C. So not C is easy. Just invert the column for C, right? So we end up with 1, 0, 1, 0, 1, 0, 1, 0. Where do we go next?
The B,
Where do
R,
we-
B, and A, sir.
Right. So the next thing that we do is that we can go A and B or C, because we could do an and. We could do either one of the ands first. All right. So, or we could do, so we taking A and the result of column 1, which is B or C. So we taking the result of this as the fourth thing that we're doing. Right? This result here is the result from the first column and A. So the fourth thing that we do is actually going to be A and the result of column 1. A and the result of column 1. So A and the result of column 1 together, we get 0 and 0 is 0. 0 and 1 is 0. 0 and 1 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. 1 and 1 is 1. So we end up getting that as a result. And the next thing that we have to do is what? We have to eliminate the ands. So we have to then take the answer for column 4, and because it's joined to an and for the answer for column 3, we have to go there. Right? We have to go there. So this is the fifth thing that we do. The fifth thing that we do is is what? Is the result of 4 and the result of 3. So we take the result of 4 and the result of 3. Oops, hold on. You'll have to give me a second. I think I foolishly did not plug in my laptop. So I'm going to have to do that in a second. We can finish this out. Okay, the result of 4 and the result of 3. So we're looking 1 and 0 is 0. 0 and 0 is
0.
0. 1 and 0 is 0. 0
0.
and 0 is 0. 1 and 0.
0. 0.
0 and 1 is
Then you have
0. 1 and 1 is
1, sir.
1. And 0 and 1 is
0.
0. And so then we move on to the last one, which is essentially the value of 5, right? The value of 5 joined on to the value of 2 with an OR, right? So this is the last column that we're doing, 6. So column 6 is 5 or 2. Okay, so we have the column from 2 and the column from 5, and we're joining them. So we say 0, 0 is 0, 0, 0, 0, 0, 0 is 0, 0 or 0 is 0, 0 or 0 is 0, 0 or 0 is 0, 1 or 1 is 1, and 1 or 0 is 1 or 0 is 1.
1.
So this is the result. What does this tell me? This tells me that when A is 1 and B is 1 and C is 0, that I get a positive result. It also tells me that when A is 1 and B is 1 and C is 1, then I get a positive result. It tells me in all other instances, I get 0. So if we go back up to where this expression was taken from, what was A, B, and C? A was true, so A was 1. B was false, and C was false. So this was essentially 1, 0, and 0. So if I look in this case where I have a 1, 0, and 0, which would be this line here, what was ultimately my result there? My result was false. So this truth table shows the case for all possible combinations of inputs. Whereas the statements, when you are given a specific input, right? This is only one case. I was only able to put A in here, B in here, and C in here. But when it resolves, if the values of A, B, and C were different, then I would be able to see the actual result, right? I'm not able to take off this highlighter that I did on this. Yes, I am. Right, on this level. But you all understand how I get each one of these values?
Yes, sir.
Right.
So you would mark it down for like write the numbers as a substitution?
No. They understand the zeros and ones, and they understand the trues and false.
No, like the 4 and 3 for the table.
Oh, that? No. You don't have to write, because if you go along each one, it tells you what it is. So if I say A and 1, essentially I'm saying A and B or C.
Oh.
Right? So it logically it makes sense. You're just using a placeholder so that you don't have to write an ever expanding set of values. Okay. All right. So I'm going to give a 2-minute break. And when we come back, we're going to take a look now. We're going to shift and start looking at control constructs, sorting and not sorting, selection and sequence, right? Or sequence and selection in that order. So 2 minutes. All right, we're back. Hope you all got up, got a glass of water or something like that. All right. Everybody's with me. Let me just see a hand raised or something if you're with me still. Here. See a couple hands. Some people not with me. Okay, some people with me. Good, good, good. Have enough people here. All right, so you can lower your hands now. All right. So we want to get into the we want to get into understanding pseudocode algorithms and flowcharts, and we have some control structures that we have to understand in order to get into programming, right? So what is a control structure? Essentially, we have three logical structures, and we have three logical structures, right? And they are basically sequence, selection, and iteration. Or if we have to say it a little more basic, okay, we have sequence, right? We have logical structures or control structures, as your syllabus would say it. Misspelling things. Control structures in programming, and we have three structures that we want to be able to learn. You have to understand first sequence, and sequence is like the logical flow of a program, step by step, stepwise refinement. Okay, it is ensuring that one process is done before another process that requires the data or requires the processing that was done for that next process. So sequence is the logical flow of your program. We have the selection structure, and the selection structure is also called decision logic. It's what your computer system or your programs use to be able to make decisions. This is where a lot of times things like your relational operators come into play, because you have to make a decision a lot of times by comparing two values and saying, okay, if this first comparison takes place, then do a particular instruction. Otherwise, do some other instruction. And the last one that we have is iteration. And this is called the looping, right? Logical structure. And this allows us to repeat instructions until some set value or some criteria is met. Today, I'm going to attempt, in the last couple minutes that we have for class, allocated to class, to talk about sequence and selection. All right, I'm going to just allow me to post a note right underneath this. Okay, with some explanation so that when you're going through this note, you're able to fully appreciate it here. So we have these three logical structures, and we have a brief explanation of each. Okay, and we are going to talk about, we're going to start with sequence. And what is sequence? As I said before, sequence allows us to be able to ensure that the program flows in a way that makes sense. All right. So I'm going to introduce to you some symbols, and those symbols would allow us to be able to allow us to make some pseudocode algorithms or some flowchart operations, some flowchart diagrams that will allow us to express our list of instructions in a sensible manner. Okay, so when we are writing a program, we want to ensure that this program makes sense. So let's say, for instance, we have a problem before us, and we know that it is the type of problem that a program can solve for us. So let's say, for instance, we have a problem that involves somebody wanting to work out, right? We have a problem where we have a person wants to work out. Or let me put it here. A painter wants to work out how much paint to use to paint a wall. Each wall is a square wall and only one side has to be painted. So each wall is a square wall and only one side has to be painted. The painter also wants to put in a square footage covered by each can of paint. Write an algorithm to solve this based on the size of, based on varying sizes of walls and different spreads of paint. Now this seems like it could be a lot. Yes? No? Yes. We have a hand up.
Seems fairly complicated.
It seems fairly complicated.
Yeah, fairly.
Fairly complicated, but it's not. All right. We have a wall. Let's just say we have a wall. So if we have a wall, and this wall is a rectangular wall, we're not going with any fancy wall. So we know in a rectangle, right, we have a height and we have a width. And we want to paint this wall. So we want to find out the square footage of this wall. And we know also we have two things that we have to solve here. We know that a can of paint, right? A can of paint is going to give us a certain square footage per can. Okay? So we want to know how many cans of paints we want to use. Right? So we want to know how many cans of paint we need to use. Let's start thinking this through. Right? If we know that one can, let's just say for instance, in this instance, one can of paint will give us 23 square feet. Wait, oh, sorry, not square, rectangular. My bad, Uma. So yes, I made a mistake here. Each wall is a rectangular wall. Thank you for the correction. And only one side has to be painted. So the painter wants to know, the painter wants to put in this kind of paint will give me 23 square feet. I want to know how many cans of paint I want to use for this wall. I have to know the width and the height of the wall. Right? And we have different spreads of paint. So we have to think about what we have to put into this problem to be able to get an answer from this problem. Are you with me here? Is it a little clearer now?
Yes, sir.
Right. So we have two things. What are our inputs? Let's talk through our inputs. Let's talk it through in plain English. What do I have to input into my system in order to get data out from my system?
The height of the wall.
The height and the width of the wall.
Right. So we have to input the height
And the width.
and the width of the wall. And we also have to input what? There's more than one thing that we have to
How
input.
much paint are you using? How much buckets of paint?
Right. How much square feet one can of paint will cover? So how much wall in square feet a can of paint will cover? So these are the two things that we have to input into our program, right? This is what we know. What kind of processing does our program have to do?
Division.
Huh?
Division.
Not just yet. Before we do the division, we have to process
Multiplication.
Right, but multiplication to find what?
The area of the wall.
Right. So we have to find the area of the wall, and that is processing because it is multiplication. And what else do we have to do?
So after we find the area of the wall,
Yes, after we find the area of the wall,
you need to
that will
divide
give us
it.
it will, you're right. We have to divide what?
By the how much square feet of paint? How
Right.
many square feet of paint each bucket will cover?
Yes. So we have to divide the area by one, by the square foot coverage of a paint can. So we have to find the area of the wall. We have to find how big is this wall. And then once we know how much wall we have to cover, we have to divide the area of the wall by the amount of square feet that we know one paint can will cover. And then what would be the output of this program? What would be the output of this program? Output of this
the amount of paint cans needed to paint the wall.
Right. So the amount of paint cans needed. So we have the amount of paint cans needed. So listen, I am sure that you're all familiar with what I have put down here. You see this input processing output. Every computer program follows this rule. Before we can even start to work out how to do a program, we need to think about what we need to put into the program, what we need to do, or what is the purpose, what the program needs to find, and what the program needs to return to us. Okay? So I know that probably in your first set of programming, IT classes, in your secondary school in Form 1, input, processing, output. I know that you would have seen your computer teacher would have said every computer does this. Have you seen this before?
Yes,
Yes,
sir.
Right? And of course, sometimes you might see this as well. And this here is a diagram that represents every computer and every computer program that exists. Because every computer is a device that takes input, processes and stores that input, and provides some sort of output at some point. Every computer program does the same. So it doesn't matter if we are programming at this level where we're now starting to learn C, or if we are programming for Google or Facebook or NASA or something. So every computer software that you write follows this golden rule: input, processing, output. And once we can take the problem identified, well, what are the potential inputs? What is the processing that needs to be done? And what is the output? Then we can easily solve the program. So we know that the inputs for our program, for our algorithm, right? And I don't think I'll be able to cover the fundamentals of the flowcharts with you all today, right? But we'll write a little pseudocode algorithm to solve this. And we will get into the flowchart next week. Okay? We are going to write some input statements to get the input values. And we have to understand that when we get these input values, we have to store them in some sort of variable. So we have to declare our variables. All right, so we have to identify and declare some variables. We have to identify we have to give input statements so that the user will know that they have to put these values into these variables. Once we do that, then we'll go on to the processing and work out the area, the wall, and do the division by the paint can. And then we have to do the output, which will ask the user to show the amount of paint cans needed. So we're going to write a small sequential program right now that will allow us, I'm going to just copy the case information that I typed out here. And we're going to write a program solution for this. Okay? So we go in again, we said a painter, this is the problem. All right, I'm going to label it as such up here. Problem. A painter wants to work out how much paint to use to paint a wall. Each wall is a rectangular shape, right? Or it's a rectangular wall, and only one side has to be painted. The painter also wants to put, or let me change that to needs, to put in the square footage covered by each can of paint. We want to know how many cans of paint we need to use. We said he wants to know, right? To just make it a little better English-wise. The objective of this is to work out how much paint we need to be able to use to paint a wall. So the first thing that we will do is that we will declare the variables. And it's okay if you miss out on it's okay if you miss out on a variable. You could always go back and stick a variable up there, right? So the variables, the size of this wall, what are we using to measure the size of this wall? Can we use, can the wall be like a size like 5.5 meters long? Or is it going to be that the wall is going to, or let me say feet, because we'll use square feet. Is it going to be 5.5 feet long, or is it going to be integers only? What is the better data type to use in this scenario? Anybody?
Real.
Real. So we can say real is the better data type to use because of the fact that the wall might have varying lengths. Okay, and what are the values of the wall that we'll have to store? We know that we took a look at it just now. The wall had a what? A width and a height. So those are some variables here, right? Width and height. Okay. And is there any other data that we need to put in? Is there any other data that we need to put in? Or that we need
Area.
How much the paint cans can cover? How much square foot it could cover?
Right. So we could say square foot per can. So we have a variable named square foot per can. All right. So we have three variables so far: width, height, and square foot per can. And are there any variables that you think might be needed for the output or that might be used in the interim?
Area.
Area is one. And any other variables?
Number of cans.
Number of cans. Now, the number of cans, is that a integer or is that a real number?
Probably integer.
Integer?
It should be an integer, right? Because
it's better for it to be an integer.
yes, because we cannot buy what you call it?
Half
Half a
gallon.
can.
Yeah, a half can of paint. Let's just assume that this paint only comes in this 1 can size. Okay? So we have the variables, the width of the wall, the height of the wall, the square foot per can and the area, and the number of cans that we'll eventually need. And if we need any more variables, we can come back and add it. But it's good practice to just think through beforehand and say, okay, these are the variables that I'm likely to need. Okay? Everybody
So
with me?
I have a question, sir.
Mhm.
Won't it be better to study number of cans? Well, for now as a real, and then afterward, you could change it to like a whole number, because entered will, like, just suppose it's 4.5, right? Enter will just give back 4 instead of
Right.
giving back 5.
Well, yes, I would go with that, and I think that's a great suggestion. I was actually going to go with some more difficult logic, but that's because I like pain. So let's not go with the painful route. Let's take the number of cans as a real number, right? And then we can also then have an integer at the end. We can have an integer at the end saying final number of cans or final cans. Let's not name it too long. All right. So I like Clemens. Is Clement who made that suggestion?
Yes, Clement.
Right. I like Clement's suggestion. Okay. Where do we go from here now? Let's take a look at our input section. And I'm just gonna I put in variables and inputs and all that in just with the headers for now. This is not something that you need to put, but I just want us to be able to understand. So this is why I am highlighting these. This is why I am highlighting these or putting these sections in bold, in capitals. So what is my input? What do I need to ask the user to do? I need to ask the user, so I could say print, and I could say enter what? Enter the width and height of the wall. And then I have a statement that says input width, comma, height. What does this tell me? I am prompting the user. I'm prompting the user to enter the width, to enter the height, and I'm storing the width and the height in the variables width and height. Afterwards, I can prompt the user again. Enter the number of square feet that 1 can will cover. Okay. And again, I do the same. I say input SQ FT PARCAN. Right? Input square foot per can. So I've taken these values inside of here. I've taken these values inside of here. So I think I've captured what I put down in my input section on this page here, right? Because I said before, input the height and width of the wall, and input how much wall square feet a can of paint will cover. And then I want to go on to now the processing. So the processing, as identified, was to find the area of the wall and divide that area by the square foot coverage of a paint can. So we have now processing. Processing is going to be where I will say area is equal to what? Area is equal to width multiplied by height. And then what is my next set of processing? The next statement, anybody can suggest it.
You have to divide the square feet per can with the area.
Right. You
So
have to divide
as
the
a
area.
statement, yeah.
Right.
So as a statement, that might be square feet per can divided by area.
Right. And where are we storing that result?
Oh yeah, you had to put the variable for it. So you could say final can. Number of cans
Right. Number of cans, right, is
is
equal
to, yeah.
is equal to what? Area divided by
Square feet per can.
feet per can. And yes, I saw Omar ask a question that says, could we make the paint kind of constant? We could, but that was not what was specified in the questions. In the question specification, it says that we are making it so that the painter could put in the square footage. But if it is that the specification had made a statement like each can always covers 30 square feet of wall, then in that instance, yes, it would be fine to create a constant called square foot per can and set that value at 30. But we are following the instructions here, right? So the painter might be buying a consistent size of cans this rounds. And so this program is allowing for that particular scenario. No problem, Omar. Right? But those are great questions, because again, a question like that, it's the difference between, providing what the user specified in terms of writing a solution and providing what you think might be the best thing. So, it's these are the kind of questions that I encourage and I like, right? So we have processing area width multiplied by height. We have the number of cans is equal, and let me put a little space between here now to make this a little more easy, to read, right? So we say area is equal to the width multiplied by the height, and the number of cans is equal to the area divided by the square foot per can. So here is where we reach the output section.
Say, wouldn't you have to calculate the final cans, number of cans plus 1 or something like that?
Right. Yeah. Well, I was actually coming back to that.
Oh, my bad.
Right. No. That's good. It's good that you're thinking. And I was going to say, what if we have two scenarios with this though, right? We have two scenarios with this. This scenario is where you might go into some decision logic,
yes,
which I didn't really want to go into at this point, right? So I didn't really want to go into at this point. So let me see what can we do, because I just wanted to deal with sequence alone at this point. All right, let's at this point, I'm going to allow for a point value for the number of cans, because I really don't want to tie up selection and sequence. Okay, so let's forget about the integer final cans for now. But when we take a look at this again next week, because I think I'll have to push sequence to next week because we're well past 7 o'clock, we will go, unless of course I see some hands up and they say, no, sir, we could go into sequence today. All right, so seeing a couple hands up, right? So we could touch on sequence today, right? But let's just leave it as this is here, and we'll just output the number of cans needed, and we'll allow for a point value number of cans. Okay? All right, so our final output would be something that looks like this. A print statement that says the number, or you will need, right, or the painter will need, and we could put a comma here, number of cans of, oops. Right, so the painter will need number of cans of paint. And the output here will be whatever number of cans that we get. So in order to test this in terms of some straight-through logic, let's input values for ourselves. Okay? So let's say, for instance, we have our variables, we have our input, and this is a sequential program here. We'll say enter the width and height of the wall. The width of the wall, let's say the width of the wall is 14 feet, right? And the height of the wall, so that's the width, and the height of the wall is 6 feet. Enter the number of square feet that one can will cover. So how much will one can cover? One can will cover 32 square feet. All right, so one can will give us 32 square feet. Our processing will work the area out to be, what is this? 14 by 6 is what? 84?
Yes, 84.
84, right? So we have 84 as the area. And the number of cans will be 84 divided by 32. I can't do any quick maths on that. That's 2 point something, I suppose.
2.6.
2.6. So my output will look like the painter will need 2.6 cans of paint. And that's fine enough for, like, if somebody, I have to ease in the painter. The paint here, right? We will need 2.6 cans of paint. The painter. And this is fine enough because a human could read that you'll need 2.6 cans of paint and you will know that you need to buy what?
3 cans of paint.
3 cans of paint. But maybe the program could work this out for you. So this is a program. This here we approach the problem using sequence alone inside of our answer. But maybe we could add some more smarts to our program, and our program will tell us, okay, well, if it is that we have a floating point value, as a result, then we can use decision logic, and we can use decision logic. Yeah.
Can we say that I have some logic saying that if the amount of cans needed, it's just now.
Mm-hmm.
If the cans needed is a float, then the amount of cans that you need to buy will be the float plus 1.
Yes, something like that.
The modulus plus, no, not the modulus. That will just give 0.6.
Yeah.
Right.
So we have to figure out a way that says, okay, if it is that we have some floating point value, in our answer, then add 1, right? Remove that floating point value and add 1 to the answer. That's what you want to say?
Yes.
Right. So we're looking at something like that.
So why add a new one?
And what we could do is that we can use a combination of integer division and modulo division to achieve that result. Should I leave these notes on here with the width and the height and stuff like that, or should I remove them and leave this without it?
Yeah. Why?
Well,
So you can leave it.
leave it. All right.
So why
All
add
right.
a new one?
So let's see how we can use some modulo division. Sorry. Let's see how we could use some modulo division and some decision logic.
Excuse me, sir.
Yeah.
I think Jariel trying to ask a question.
Wait,
Oh,
Mike,
sorry.
no start to work, sir. Why add a new one to the finals?
Right, because in the case of this, we don't want that 2.6 cans of paint once the is the answer. We want 3 cans of paint.
Want to get
A
extra?
discrete number.
Yes. So yeah, you don't want to ever have less. But in
Yeah.
the case of 2.6, you can't buy 0.6 cans of paint anyway.
Yes, sir.
You follow me?
Yeah.
So we taking the same answer, but we modifying the processing a little bit. Okay, so this first one, we just simply, right, we're in the solution. Why am I not able to edit? Hold a second, please. All right, I'm going to have to restart this program yet again. I don't know why it's just behaving like that today. But, okay, and we're almost done. We had the last 15 minutes of the class, if so much. Right, but I want to put in here, now this is our solution using only sequence. Okay, and it makes sense. This solution makes sense. This solution isn't wrong, but we really and truly, being good programmers, we really and truly wanted to simply get a output where the cans of paint is an integer value cans of paint.
Question.
So yes, we have.
So if you have 2.6, right, and you use modular division to divide by 1, and so you'll get 0.6?
No, because modulo division it works on integer values. So we're going to have to change the nature of some things inside of here.
Okay, sir.
Right? We're going to have to do a little bit of working around inside of here. Right? Now we're going to make an assumption. Once you utilize modulo division, it's being performed on the integer values inside of here, right? Or you're gonna get right. I know what we will do, right? It'll be bending the rules a little bit. We'll be bending the rules a little bit because of the fact that we are in pseudocode algorithms. All right, but we will move accordingly. All right, so let's go. All right, so we're ready. So we have integer division and add 1 when getting the yes, but what if you get a perfect number? So let's say, for instance, this is where we talk things through. This makes sense. I like that response that Omar says that you could use integer division and add 1 when getting the number of cans. But what if your width by height, let's say, for instance, we entered a width of 20 and a height of 5, which should give us an area of 100. And let's say, for instance, that the number of square feet that 1 can will cover will give us, the number of square feet that 1 can will cover will give us 10 square feet per can. Okay? You see where this is going here? Yes or no?
Yes, sir.
Right? The number of cans that we get when we divide the area by square feet per can is going to be 10. But if we use that rule, assuming that we will almost always get some integer value, right? Assuming that we will always get some integer value, then we will end up saying that we need 11 cans of paint using the solution that Uma had. More times than not, it will be correct. More times than not, it will be correct. But what about that one time that you make the painter buy the can of paint when he or she didn't need to buy that can of paint? Understood?
Yes, sir.
Right? So this is what we're going to do, right? We're going to you'll have me thinking through multiple solutions here. Okay, so we're going to enter the width and height of the wall. We can get a real number value there. We can enter the number of square feet that one can will cover. We'll get a real number value there. Right?
This was be sharing your screen, sir.
Oh, sorry.
Yeah.
I thought I was. I forgot that I restarted the application and it didn't share. Okay, right. So I didn't even see what I typed in the example there just now with the 20 and the 10. Oh, sorry, the 20 and the 5. Right? And the can of square, the square footage for each can is 10, which would give us 110 here. But then if we just decided in all instances to add 1 to the amount of cans of paint, we'd end up with 11 cans of paint when we needed 10. All right? So, all right. So in order to solve this, actually no, I don't want to go into this now, and I will tell you why. It is because I have a couple functions to explain to you all, and I don't just want to do it willy-nilly. So I will elect to end here because there are a couple functions that I will have to use to get this to work in the way that I want it to work, and I haven't introduced those functions to you yet as something that we can do. So sorry for leading you all into thinking that we can go into the sequence tonight, but I wouldn't do it because then I would have to go on too long. Right? So what we would do is that we would pause here. I will put up another question similar to this, sequence alone, that you can take a look at. Now remember, when you post on the Google Classroom, this is for discussion amongst yourselves. It's not only me to say it's correct or something. So if somebody posts up and you look at the solution, and you can say, yes, this is what I got to. Yes, I think this will work. And Jamira will chime in as well. But there's a lot of you all. I can't go through all the solutions, but we will take a look. So look out for the next sequence exercise. And next week we'll recap on sequence and we will go into selection, because I do think that we might go a little longer than we need to. All right. Just to recap what we did today. We spent quite some time recapping variables, constants, operators, data types, truth tables. We went through, all of these things once again. We actually did some evaluation of expressions for utilizing Boolean data types. We did some truth tables. We took a look at the introduction of what each one of these logical structures are. We only got to sequence today, which means that maybe next week I can squeeze in decision and looping. And we did an example where we looked at input processing and output, and the role of input and processing and output in working out a question in a sequential manner, and taking a look at a particular problem and getting a result towards it. All right, so we did do a lot today. I don't want to overload and I don't want to extend because I'm looking at the time and we are not going to be able to make that adjustment immediately. So next week, same time, I'm going to put up the question for us to attempt. We're going to discuss it on the classroom, and then we're going to meet back here next week where we will take a look at the answer and go into selection. And we could use the same example, go into selection and go into maybe some looping as well. All right. Real.
Yes, sir. So I want to ask a question about the modulo division, sir. Is it just common to this programming language that it doesn't work with real, or is it throughout all the different programming languages?
No, modulo division is a form of integer division. Remember, it returns the whole number remainder, right? So again, just to recap on that. Just to recap on that, it's if it is that you have the integers, right? 9 modulo divided by 4, right? It returns, remember, a regular division, a regular integer division, 9 divided by 4 will give you 2. This gives you the remainder, that one value there, which will be 1 over that 4, which could then be translated into that real number, 1 over 4, which is equal to 0.25. Understood?
Yes, sir.
All right. All right. So we'll pause there because I really have some other commitments. And I will see you all next week. So any questions again before we leave? Sorry for thinking that I could squeeze in the sequence, but I really couldn't. Any other questions before we leave?
No, sir, that's fine.
Say, can I ask you something after everyone leaves, please?
Yeah, no problem. Right. So that's it. I'm gonna stop the recording now.